Hello and welcome to this Gagemaker webinar. Now I would like to introduce today's presenter, Eric Otten. Eric is the Vice President of Sales and Marketing at Gagemaker. Eric, welcome to today's event, and with that, I'm going to pass things along to you to get us started. Eric, go right ahead.
Hello everyone, my name's Eric Otten with Gagemaker in Houston, Texas, and welcome to our webinar. This webinar is about the benefits of implementing a precision horizontal measurement device in your facility, which we're going to call a PHMD from here on out. And I'm really excited to hear from you at the end of our session. We'll be fielding some questions during an active Q&A segment. The webinar will be available online for subsequent viewing. Let me tell you a little bit about myself and my background and experience. So for the past 2 decades, my experience involves operations, manufacturing tubular products for oil and gas, precision measurement, and then thread inspection, and then also some experience with calibration equipment. So purchasing precision measuring equipment can seem very daunting given the initial upfront expense, but when you appropriately deploy it and utilize this equipment to its capability, that initial return on investment occurs very fast. So the name of the game is versatility, accuracy, and flexibility. And this webinar is going to explore the pros and cons of choosing a PHMD over other common traditional devices. And we're going to demonstrate the 4 ways to accelerate your return on investment and provide you insight on why your facility may be missing out by not owning and operating. So now let's give some detail on what a precision horizontal measuring device, or as I said earlier, a PHMD is. So it's a highly accurate benchtop piece of equipment. It's typically made up of a combination of a single-axis, very precise linear bearing, and also an ultra-high accuracy scale. And those 2 things are used in conjunction in a shop or laboratory for part measurement, gauge setting, and then for calibration. Some of the names used to describe a PHMD are a linear measurement device, a measuring master, sometimes they're called presetting or calibration benches, an industrial length master, or a universal type measuring machine. And then the one we offer is a TRAC. So now that we know what a PHMD or a TRAC is, let's talk about who needs one. In our opinion, everyone does. Basically, any facility that's performing receiving inspection, facilities that perform threading operations, especially in oil and gas sector, companies that have a dedicated calibration lab or a gauge lab, there is a definite need across all these major manufacturing industries, aerospace, automotive, energy industry. Basically, if you don't have one, you're missing out on these benefits. Everyone should have a PHMD. Let's start by increasing sales. Owning a PHMD expands your capability and essentially grows your shop floor capacity. How? The versatility involved with these types of machines allows your facility to immediately measure parts or set gauges with extremely high accuracies on a greater variety of applications. That speaks to brand recognition. The high accuracy measurements that follow by deploying a PHMD elevates your level of quality, which is in turn going to improve the product you produce, and your industry credibility follows suit. That means less time wasted waiting on outside suppliers. It's putting the control back in your hands, saving you time and money. All of that lends itself to your return on investment. Let's look explicitly how. As we said earlier, the purpose of this webinar is to highlight the 4 ways you can increase your ROI with a PHMD. Let's explore those 4 ways. Number 1, gauge setting. No more need for gauge blocks or expensive dedicated masters. Use the PHMD's versatility to set gauges with very minimal training. Number 2, part measurement. Part measurement can be one of the most difficult applications in any manufacturing or receiving inspection application. But part measurement with a PHMD is easy. Again, utilize the right fixture and measure away. Number 3, shop versatility. So realize the immediate benefit on the actual shop floor by being able to do things you couldn't do before. Essentially, you're diversifying your business prospects by being able to do a greater range of applications or take on jobs in industries that maybe you couldn't bid on before. Number 4, calibration. No other benefit is as invaluable as this one. Every instrument calibrated in-house saves time and money, and all that goes straight to the bottom line. So common industry-wide practices for presetting, setting, or standardizing hand gauges is to utilize tools that are typically available in the shop. So these may include OD and ID mics or micrometer-style gauges. Gauge block stack-ups are very popular, or Joe blocks, calipers, and then of course dedicated setting masters or fixed limit gauges. So in contrast with the typical methods I just named, we're also going to look at the benefits of setting gauges with a PHMD, like a mic TRAC. While there are pros and cons associated with each method, let's investigate further. First, let's examine using a dedicated setting master. So the pros are immediately obvious. They're accurate. It takes minimal training because they're robust, pretty much dummy-proof design, and it's a simple concept. However, the cons easily outweigh these benefits. So what are the cons? Well, first, setting masters, depending on how often they're used, tend to wear out over time. They're non-adjustable, so that means you require multiple sizes and types, and you may end up needing a lot of them. Storing a host of setting masters takes up space in your lab or shop and gets expensive very quickly. Ordering non-adjustable setting masters comes with other headaches like long lead times. They're often made to order, so they're not easily replaced if damaged or lost. In addition to dedicated setting masters, gauge blocks or Joe blocks present an equally popular method for gauge setting. Compared to setting masters, gauge blocks present a much wider range of versatility. There's no real loss of accuracy, and most shops have some on hand, and if they don't, gauge blocks are easy to get. Now, the cons are also apparent. So operators are prone to making mathematical errors during the stack-up process. Gauge blocks are small, so they tend to get dropped or damaged, sometimes even lost. They require expensive calibration, and users often need training in order to achieve the right gauge block stack-up for the setting value. Now let's take it a step further and compare to micrometer-style gauges. So every machine shop has a set of OD and ID mics. This is a very common practice to measure product with them and set gauges with micrometer-style instruments. However, doing so can be very cumbersome. It's time-consuming, and now this is where you really start to see a loss in accuracy as opposed to a dedicated setting master or the accuracy you achieve with gauge blocks. In addition, while they're adjustable, that range of adjustability is limited. It's based on the range of the instrument, so you still may need multiple OD and ID mics to achieve the same task that you could with one robust PHMD and some fixtures. So summarizing the pros, you have that limited adjustability. You still have some accuracy and they're readily available, but the cons are they're fragile instruments that have to be individually calibrated. They add to your operation cost. And then there's that loss of real accuracy compared to the other setting masters we just discussed. So let's highlight the example of a MRP gauge that's used for oil and gas pipe threads. That style of gauge involves an indicator and contact shoes. And here, if you look at the exploded view, you can see the anvils are going over the shoes, and these are the anvils of the OD micrometer. So in order to set the MRP with an OD mic, you have to adjust the OD mic using the thimble, lock it into place, sweep over the shoes up and down, back and forth, very cumbersome, and then zero the dial. So it's much more cumbersome, less accurate, and time-consuming than compared to a PHMD. Now let's present the value proposition of setting that same MRP-style gauge, but on a PHMD mic TRAC. So I've installed proper fixtures for the application. I've dialed in a setting value, locked it in, so it's now mimicking the robustness and the accuracy of a dedicated setting master. But if I want to change the setting value, all I do is dial it in and lock it down again. I don't have to go out and purchase another setting master. Because of the geometry of the fixture, I put the MRP gauge on, I date them off the face, I zero the dial. Don't really have to do any gross sweeping like I would with a micrometer or a set of gauge blocks. Very robust, very simple, too easy. While clearly the best option there can be some negatives. And typically the first thing that comes to mind is there's a high initial upfront cost when procuring a PHMD. There's some limited portability. You have to have somewhere stable to place it. And if it's damaged, this is a substantial piece of capital equipment, so it could be expensive to repair or calibrate. However, this doesn't even come close to approaching the value proposition that a PHMD like a TRAC offers. Now let's explore the benefits. Number one, the ease of use. There's nothing else like it. Dial in on a digital readout or an attached PC on a PHMD, the setting value with almost infinitesimal adjustment, too easy. The fixtures, I can't stress enough, using the fixtures to leverage the unit to its fullest capability just allows for such a variety of measurements and setting gauges, and later you'll see calibration. And you get to achieve all this without any loss in accuracy or repeatability. That's the key. It's fast and reliable, easy to use. So the second way to achieve a quicker ROI with a PHMD is to utilize the unit for part measurement. So traditional part measurement typically involves OD, ID mics, micrometer-style instruments, hand gauges, calipers, and even go, no-go gauges. And then you can go as far as something very accurate like a CMM. So there are advantages to using the hand gauges because they're already available, and that's the most traditional way to measure a part. And there is some versatility there. And then for a CMM, the biggest pro is they're extremely versatile for difficult geometries, and they're very, very accurate. However, when you're comparing to a PHMD, the hand tools have limited accuracy, and they're not dimensionally stable. So there's repeatability and reproducibility issues from one operator to another. And you really need a huge assortment of gauges to achieve a practical range of measurement. So on the CMM side, while these units are extremely versatile and have very high level of accuracies, the buildings and facilities required to house a unit like that, they're big. It takes up a large footprint. There are environmental conditions that have to be maintained. And then a person can't just sit down and start using one of these types of devices. You have to get training, and they also don't have the durability to be out on a shop floor. They need to be in this controlled, almost laboratory-like environment. So in contrast, let's consider measuring parts with a PHMD. So number one, this unit can be right out on the shop floor. Parts can come right out of the machine, go straight to the measuring device, and utilizing various apparatus and fixtures and support tables to be able to do a whole variety of parts. So let's examine some of the pros and cons of measuring parts with a PHMD. So these benchtop measuring devices, they realize immediate cost savings because they're only a fraction of the cost of a CMM. The CMMs and probe-style instruments or arms, they often go unutilized because of the amount of training it takes to get these going. So a PHMD, you can measure parts immediately, right on the shop floor. The accuracy is there. There's high reproducibility, so you're not going to have a lot of error fluctuation between operators. Some of the cons, there is a change over time, just like any other machine, a need for fixtures and some additional accessories. But the real value is being able to take that machine right on the shop floor, measure product right as it's coming out of the manufacturing environment, just by utilizing the appropriate accessory and the right procedure. The third way to achieve a faster ROI is by harnessing the PHMD's adaptability. So this quick changeover functionality and the versatility of a benchtop device like a TRAC lends itself to growing your facility's ability to try new things or dive into different markets. For instance, if your shop is considering quoting a job that requires specialized gauge setting or part measurement, you may be hesitant on bidding for that job, given the typical long lead times and expense of custom measurement options. In contrast, a PHMD allows you to simply add just the right accessory or fixture to get the job done, and you've shifted your reliance from outside services to your own in-house capability. In addition, the ability to measure a part, right on the shop floor on a mic track or other PHMD trumps having to send a part to a laboratory environment and wait on, a costly setup or programming of a CMM type instrument. Equally important, more and more customers are mandating documented quantifiable measurements given all the liabilities involved in manufacturing these days. So what better way for you to provide this to your customers than to utilize that already built-in accuracy and function of a PHMD? So that'll help us segue into more detail about accessories and fixtures. The upfront cost of a mic track or PHMD style device can be significant, and leveraging that capability to the max is going to be the most important part of your equation when trying to break even as fast as possible on that investment. The ability to accessorize your measuring device with high utility style fixtures, that's a sure way to accomplish that goal. Let's explore it further. As illustrated here in the graphic, you can see there's a host of different accessories and fixtures for horizontal measurement devices. So these can be used for gauge setting, some are specialized for part measurement, and others are tailored exactly for calibrating these hand tools. On the screen now, you'll find a basic calibration procedure card, or CRC, that provides the best practice for installing this specific fixture on a mic track or a PHMD. Specifically, this example shows step-by-step how to use TF2Rs on a mic track to measure product or take over-wire measurements. While this is one of the more simple accessories, if you look closely, you'll see the round anvils resemble the ends of a typical OD micrometer. By installing this particular fixture, you can perform on-site measurement of gears, threaded components, you can take over-wire measurements, but now with an increased accuracy that's not typically possible with the traditional methods like an OD mic, and without all the inconvenience and hassle of operating a CMM. The fourth and most beneficial way to accelerate your ROI with a PHMD is to utilize the fullest capability of the unit along with fixtures for in-house calibration. Calibration is typically performed one of three ways. So the most popular yet most expensive way is to send to an outside service. This is typically an independent contractor or dedicated calibration house. Another alternative is sending out to the OEM manufacturer of the instrument. Secondary to that is hiring a firm or a contractor to come on site to your facility, but that's equally expensive. The best option is creating an in-house calibration system yourself. So if you're calibrating by sending to an outside source, there's some headaches that are involved with that. One, you have to send out the equipment. So there's going to be time spent outside of your facility where you can't use that instrument. You're basically at the mercy of the outside service. There's the added expense of paying someone to do this. There's sourcing a service that you would actually trust. And then alternately, if you had an outside service come on site, being able to schedule that, the downtime that's going to be involved, accommodating them at your facility, insurance and safety liabilities, and ultimately, who do you trust? The best result typically comes when you're in control of the process yourself. While calibrating in-house is ultimately the best possible solution given the cost savings, keep in mind there are some challenges. That initial expense of the equipment and fixtures, training is involved, and it's possible that you may need to maintain conditions that are conducive to a laboratory environment, depending on the type of calibration you're going to perform. Implementing an in-house calibration program has immediate benefits. Number one, being in control of your schedule, being able to calibrate on your own time, that reduces downtime. If you have an urgent demand, let's say somebody drops an instrument or something's been out of service and needs to be placed back in service, you have that control in-house to be able to handle that immediately without waiting on an outside service. It improves your quality both directly and the perception that you're demonstrating competence in your facility. It's strengthening the traceability of your product all the way through the inspection and calibration process. And bottom line, it saves money. Let's talk about direct cost savings. So industry-wide, the average calibration price can vary from $50 an instrument to over $100. So conservatively, let's use $60 an instrument as an example. If your shop has 250 instruments, that's $15,000 a year in calibration costs. That's the price of a typical PHMD in combination with fixtures. So in less than 1 year, you've already, by leveraging that ability, you've already paid for the instrument. So now we're going to go into a little bit more detail on examples of instruments that you can typically calibrate in-house, and then the respective fixture that you would install on the PHMD or the MicTrack in order to calibrate that device. Let's start with depth micrometers. The fixtures involved are a TFDG and TFSS. It's basically a combination of a clamp to secure the depth gauge base and a shelf to rest the depth rod during the calibration process. For OD and ID Micrometer-style gauges and their respective rod setting standards, we use a fixture called TFSVs. Basically, it's a V-shaped fixture, and the anvils rest inside the V and are aligned for easy calibration. The same principle holds for the rod standards. The OD of the rod rests in the V, and the flat ends contact the precision anvils. Dial indicators. A TFIND is basically a vertical post with a hole and set screw to secure during the measurement process. Test indicators. Basically a combination of a TFTI support stand and TFSS fixture, which is a specialized version of a precision anvil, a support stand, and hook to traverse the probe during calibration. Calipers. The TFCA fixtures are a combination of two clamps to secure the jaws, align them to the axis of the measuring scale, and a support arm to hold the instrument during calibration. For bore gauges and pivot arms, we use a TFVB or a TFVN fixture. One is a V-shaped clamp to hold the pivot arm style instrument, and also the TFVN is a V-shaped base for 2-point bore gauges. For straight plugs, the TF2R precision anvils and the respective thread wires and holders are used during calibration. For a tapered plug, the TFTP fixture has a slanted base for proper orientation. And for threaded rings, the TFSP fixture is perfectly suited with probes and ball contacts designed to ride in the helical path of the ring gauge. All these can be used in combination with multi-axis support tables for the most accurate results. So what's to be considered when shopping for a PHMD? Number one, you need to consider the value proposition. What is the price? What's the level of accuracy and repeatability required for your needs? Look at the shop floor durability of the unit. Is it suitable to be on the manufacturing floor, or does it need to be in a strict, environmentally controlled laboratory? What are the maintenance and repair costs? You need to consider the size range based on the application and also the ease of use. But the number one factor and the number one determination of the value proposition is the versatility. Are there fixtures and an assortment of accessories available so you can leverage the full capability and value of your MicTrack or PHMD?
Gagemaker MicTrack calibration and gauge setting systems are completely customizable. If you only need to set a measuring instrument or verify a gauge is calibrated, then we've got you covered. The Gagemaker MicTrack 3000 is a versatile bench-mounted gauge setting and part measurement system with gauge lab accuracy and shop floor durability. This cost-effective solution measures parts, calibrates handheld instruments, and presets indicator-style gauges. Many factors come into play when choosing a calibration and gauge setting system: accuracy, repeatability, versatility, cost-effectiveness, ease of use. Get the process started and contact Gagemaker at 713-472-7360 or visit Gagemaker.com.
As you saw in the video, a MicTrack 3000 is fully customizable and upgradable given the large variety of fixtures, accessories, and software available. It's the perfect complement to any shop for use with gauge setting, part measurement, and in-house calibration. Considering the built-in accuracy and the ease of use, no other PHMD presents a better value at this price point. A MicTrack 3000 in your facility is your ticket to the fastest return on investment. Accelerate your return on investment by using fixtures for both gauge setting and part measurement. Save time and money by being in control of both your manufacturing and inspection processes. And harness the adaptability and high level of accuracy of a PHMD like a MicTrack 3000 by implementing an in-house calibration program. You'll find the unit pays for itself in no time. In summary, leveraging the full capability of a precision horizontal measuring device such as a Gagemaker MicTrack 3000 series presents an excellent business case for lowering costs and attracting new customers, new projects and markets, and elevating your quality. Thank you all for joining us today. I hope you found value in our webinar, and I look forward to hearing from all of you. If you have interest in any Gagemaker products and services or any of our offerings, we encourage you to contact us via email, social media, or by calling our office. We have a host of technical experts, industry authorities, and customer specialists ready to help. We hope Gagemaker will be your first stop for all your metrology, thread inspection, and precision measuring solutions. Thank you.
Okay, great. Eric, thank you so much for that great presentation. We are going to move into some questions that have come in from our attendees. So let's start off with the first question here. Can this device calibrate adjustable ring gauges?
So the answer to that is with the appropriate fixture, you certainly can, but there's different rules on whether or not that is a valid calibration, depending on what specification you're holding to. So what's typical is an adjustable ring is usually calibrated with something called a set plug. So oftentimes people will take the set plug, calibrate that on the PHMD or the MicTrack, and then take the set plug and calibrate the adjustable ring gauge. But it can physically do it. It's accurate enough. And at some point, the ANSI specs may allow that. Right now, they want you to use a set plug.
All right, great. Eric, thanks for that answer. We're going to move on to the next question that we have in here. How many instruments make sense to buy a MicTrack?
Okay, so that question is really, you have to look at two different avenues. One, if you're talking about part measurement, then you have to compare it to, what is the comparable method. So if you were buying dedicated setting masters, let's say those cost on average $500 each. Well, the setup that we're showing in the video of a MicTrack and the appropriate fixtures to set gauges, that's typically around in the neighborhood of $15,000. So if you had the choice of either purchasing 30 $500 dedicated setting masters, then you may as well go ahead and buy a MicTrack because you're already at a break-even point. Everything else from there is gravy. If you're looking at calibration, typical calibration costs, like we said in the webinar, are anywhere between $50 and $100. So back of the envelope math, if we were choosing $60, to answer your question, how soon do you want to break even on that investment? If you want to do it in 1 year, if you have 250 instruments times $60, that's $15,000. The instrument has already paid for itself.
All right, great. Thank you for that answer. Just remember, everybody, if you want to ask a question, go ahead and enter it in that box and click submit. The next one we have here, Eric, is what is the typical break-even time after implementing in-house calibration?
So I think I've kind of answered that one in the previous question. So if you're doing somewhere between 200 and 300 calibrations a year based on that cost, you're looking at 1 year or less on your return on investment. If it's part measurement, you need even, gauge setting, you need even less instruments because those setting masters are typically in the hundreds of dollars, so it could be just 30 or 50 instruments to break even after a year. 1 year is very reasonable.
Okay, great. Thank you. We do have another question that popped in here. What is the standard accuracy needed to calibrate hand gauges?
So a good rule of thumb is whatever the hand gauge is, whatever its accuracy and resolution, let's, for example, use a dial indicator that has 1/1000th graduation in accuracy. So a typical rule of thumb is you'd like to be 5 to 10 times more accurate with your traceable setting calibration device than the instrument you're trying to calibrate. So if I was trying to calibrate a dial indicator that has a 1/1000th of an inch accuracy, I'd want my mic track to have at least 1/10,000th or 50 millionths accuracy if you want to get even higher to 20 times.
All right, great. Thank you, Eric. Another question I have here is a mic track appropriate for a shop floor or a laboratory setting?
So really it's best for both. It depends on how accurate you want to keep your measurements. So if you are in a laboratory and you're actually calibrating, true certifiable measurements are taken at 68 degrees Fahrenheit and 50% humidity, and that's probably very difficult to maintain on a shop floor, but that's where you get those true certifiable dimensions and you can maintain the full accuracy of the unit. If you're measuring parts or you're calibrating some hand tools that don't require the extreme accuracies of the unit, it can absolutely be on the shop floor. And nothing is going to happen to a mic track on the shop floor. It's built to be in different conditions, but you always want to maintain whatever instrument you're if you're calibrating an instrument or you're measuring a part, you want the temperature of that component to be as close to the temperature of the mic track, because we all know things expand and contract with temperature changes. So if they're dissimilar materials, basically you want them at the same temperature when measuring.
Okay, great. Thank you so much. Another question we have here, how often does the measurement device need to be calibrated?
So in this question, I assume we're talking about the PHMD, and we recommend anywhere from 6 months to 1 year. These are typically done with lasers, not with gauge blocks or something like that, because if you hold a gauge block, the temperature can affect the accuracy of the calibration, so you'd want to use an appropriate procedure in laser interferometer. If you're talking about the hand tools that you're calibrating on a mic track, industry standard is 1 year, but you can also look at the history of the instrument. If you have some history and look at various calibrations and the values on the instrument aren't changing, based on your quality program, you could make the intervals longer. But 1 year is typical.
Okay, great. Thank you. So we do have a question that just came in, Eric, asking, are special blocks for MT3000 available according to customer drawings?
Yes. So Gagemaker can manufacture custom blocks and custom fixtures. And matter of fact, we do that quite often. And our anvils on our mic track, those are not anvils, the receivers that receive fixtures. Sometimes we call them anvils. Those are made where we can make custom or give catalog style fixtures.
Okay, great. Another question here. What is the average cost of outside versus inside calibration services?
So the way to answer that is, it's typically $50 to $100 a piece for outside services. If you're doing it inside, once you've paid for the unit, let's say after that first year, now you're just looking, you already have the fixtures, you already have the equipment, you're looking at the burden rate of your shop, and typically there's a dedicated employee, so that labor cost just to operate the track, but now that capital equipment's paid for after a year. So really after a year, it's just labor and your burden rate of your facility.
Okay, great. So this is kind of along the same lines of cost. Another attendee just wrote in asking, what is the associated cost to calibrate the PHMD mic track? So you may have just touched on that, but just another question about that. Yep.
So depending on the size of the linear measurement device, the mic track, so ours start at 12 inches as the smallest, and typically a catalog one goes all the way up to 60 inches, but we've done longer than that. So the longer they are, the more expensive they are, and there's typically some cost associated with the amount of time that you're not going to have the unit. It has to come to us because it's very sensitive. It has to, we call it soak and get to temperature. So you're looking in the hundreds of dollars to calibrate one of these on those typical intervals, and usually it's once a year. But it could get up close to under $1,000 for the highest accuracy and the longest scale. So in the hundreds of dollars typically per year.
Okay, great. Thank you for that answer. Again, anyone who wants to type any questions in, type them right into your Q&A window there and click submit, and we'll get to those. Another question we have right now is, can you calibrate ring and plug gauges?
So yes, you can, and it also, again, depends on what industry that the specification is applicable to. For instance, if it's an ANSI ring or plug, there are specifications that give the accuracy requirements on those, and we have the fixtures for threaded rings, threaded plugs. Like I said before in an earlier question, if they're adjustable, you want to use the fixture and calibrate the set plug, and then use that to calibrate the adjustable ring. But it can certainly fit on the machine and be measured. If these are API, that's American Petroleum Institute, tapered rings and plug gauges, the unit is accurate enough and there are fixtures available to take the measurement, but those have certain rules and they have to interchange with master gauges. So while you could take the measurement and know that the product is good, it's not necessarily certifiable under API unless you do that interchange with a master ring and plug. And then the most common type of tapered threads in the world are NPT threads. So we have a special fixture, as you saw in the webinar, that calibrates NPT plugs, and very simple. And so if that answers your question.
Sure, great, thank you. Another one just came in. What features and capabilities are added with the MT4000?
Okay, so that's a great question. So let me discern between a MT3000 series and an MT4000 series. So number one, an MT3000 series is really for three things: the part measurement, gauge setting using fixtures, and then calibration. However, on the MT3000, there isn't the required accuracy to calibrate the threaded rings and plugs. When you want to go to that level of accuracy, you need an MT4000. An MT4000 is set up really exclusively for part measurement and calibration. And it has dual axes on it, meaning there's more than one scale, and the scale can get accurate all the way up to 20 millionths of an inch. And that's the type of accuracies and precision you need for rings and plugs. And also on the 3000 series, there is a load cell as a feature. So if you were measuring product and you wanted to put the same amount of force between the anvils every time, that load cell will trigger. We call that force lock. And always, let's say you set it at 2 pounds, when you bring the anvils together, as soon as it sees 2 pounds of force, it's going to freeze the readout and give you that reading. On the 4000, instead of a load cell, there's actually a weight and pulley system. So it's extremely accurate, and there are rules based on what wire sizes you use. If let's say you're calibrating a threaded plug gauge or a threaded product, and you're taking an over-wire measurement, depending on the pitch of that thread and the wire size you're using, there are certain rules of how much force, how much weights you would put on that Microtrack 4000. So the main differences are the accuracy, the intricacy, the dual axis on the 4000, and a weight system versus a load cell. Good question.
Okay, great. Thank you so much. That was good. So we have two different questions in here right now. Both of them are in relation to the environment, so I'm just going to kind of put them together. Does the Microtrack have to be housed in a climate and humidity controlled environment? And like I said, there's a couple questions about that environment. So if Eric, you want to answer those?
Sure. So basically on the climate and humidity, typical, let's say an ISO 17025 accredited calibration laboratory, they have to maintain that 68 degrees Fahrenheit and 50% humidity, and just plus or minus a couple degrees. But if you're measuring product, it's okay for it to be out in the shop floor as long as the part and the Microtrack are at similar temperatures. Let's see, you said there's some specific questions underneath that one?
There were just a few attendees that had asked about the environment, so I think we kind of got that covered with kind of combining all of those together. So
good rule of thumb, just in summary, is 68 degrees Fahrenheit is the golden rule. Anything outside of that, you just need to take into account thermal expansion.
Okay, Eric, thank you. That was great. We do have more coming in, so let's just keep on going.
Okay.
Does the TRAC have an associated software system that creates a calibration report when calibrating in-house?
Yeah, so I think what he's meaning there is a calibration report or a calibration certificate. So the software associated with a TRAC, that's the software we designed, called Certify. And Certify automatically comes with a TRAC 4000 series, and then it's available as an upgrade for a TRAC 3000 series. That software allows you, it basically lets the TRAC talk to the computer instead of a digital readout. So when you're taking readings, they automatically populate in the tables, and they generate a cert. So if you buy right now an instrument from Gagemaker, whether it's a TRAC or anything else, we use that software in-house to create our ISO 17025 accredited calibration report. So the answer is yes, and the software is called Certify.
Okay, great. Thank you. We do have time for more, so we're going to take this next one. This is from the same attendee that asked a question before, so it's kind of a follow-up. Can the MT3000 be a replacement for frame standard for API 5B?
So the answer for that is with the appropriate fixture, you could use that as an equivalent. So in API 5B, the latest edition is the 16th edition, and they basically give 3 different conditions. So flat standards, that would look like a rod standard. Frame standards, which are preferred, that's a rigid fixed limit setting master that's tapered just like the threads. But there are fixtures called TF75T and TF1T, and that stands for 3/4 taper per foot or 1 inch taper per foot fixtures for measuring or setting gauges on a TRAC that it's okay to do with API 5B. It meets the accuracy requirements. There's a section 7 in API 5B, and that tells the accuracy requirements, and a TRAC meets that.
Okay, great. Thank you. So another attendee asked, is the training certification available from Gagemaker for calibrations performed using the TRAC?
Okay, so typically we don't do formalized training. It's really not necessary, but we do have orientation. And then earlier in the webinar, you saw we had an example of something called a CRC, a calibration reference card. Those are available for free via request, and basically we give you a link, and you can download them. And it's a procedure step by step, including using the Certify software, and it's from beginning to end. So soup to nuts on that, basically cleaning the fixture, installing it, and calibrating using those CRCs. And if we trained you to do it, we're going to use that exact same procedure. So the best way is use the CRCs as orientation, and then on a daily basis, you'll be able to use that instrument. We sell hundreds of these a year, and people are able to do it on their own.
Okay, great. So everyone out there, we do have time for a couple more. If you have a question, go ahead and enter it in the Q&A window and click submit. Eric, we have one last question in here right now. So this will be our last one unless anyone decides they want to ask something else. So the last question we have right now is, are there different fixtures to use with different tools? And what are the most common?
Okay, so that's a great question. So there are different fixtures, and if you go to our website on www.gagemaker.com, you'll be able to go to the reference section, and there is a poster, and it shows basically every kind of hand tool you can imagine. Examples: Micrometer-style, dials, fixed limit gauges, calipers, depth mics, you name it, it's on there. And across from it shows the appropriate fixture you would use to calibrate that hand tool. In addition, for the most common, we have something called a Cal pack, C-A-L-P-A-K, and basically that means a calibration pack, and it's a host of fixtures to basically do anything that has an indicator on it, calipers, depth mics, rod standards, and then some other specialty gauges. But if you start with the Cal pack, that's your best bang for your buck. It handles all those common tools.
Okay. And it looks like those are the questions we got today. So we are going to wrap everything up right now. Eric, I want to thank you so much for being here with today, and thank you to all of our audience members for being part of this webinar event. Eric, that presentation was great, and we had some really great interaction with the attendees there, so thank you.
Awesome. Well, thanks a lot, everyone. I hope you enjoyed it and that you learned a lot, and we look forward to hearing from all of you so we can help you with your existing mic track, or if you're interested in one, you know where to contact us, Gagemaker.com.
Okay, great. Thank you. And I just want to say thank you again, everyone, for taking time to attend this webinar event. Take care, and we will talk to you all soon.